Good evening, student. Today we will demonstrate one of the most important experiment of physical chemistry M.Sc first semester, that is determination of pKa of benzoic acid by pH metric method at room temperature. As you know that such type of demonstration, we will first discuss the theory and principle of this pH metric method, and in second part we will perform the experiment, and in third part, on the basis of your result, basis of your observation, we will determine the pKa of benzoic acid. Now, there are many practical books are available in our library, and I think you have already gone through all those practical books. And one of the most important practical book is physical chemistry experiment, that is by Alexander Findlay. But for this particular pK of benzoic acid or ionization constants and other things, there is a very famous book which is available in our Sundarlal Sharma library, that is the determination of ionization constant, a laboratory manual, 3rd edition, Albert and Sargent. It is a very famous book, very old book. So if you gone through this book, you will get some exact result so that you can compare your result with the literature values. As you know, it is a very simple experiment. For determination of pK, we need a pH meter, and we are having many simple pH meter in our laboratory. We need one microburette and some chemicals are required, buffer solution like that, and when we will perform the experiment, I will show you the quality of the chemicals and how you prepare that buffer solutions. So there are two parts. First part is that calibration of that pH meter, or sometimes we call it a standardization of the pH meter. And you know that there are two types of electrode. One is Kallol electrode and another is the glass electrode. But I think in your laboratory you are having a combined electrode, so that is not a problem. So first you will prepare 3 buffer solution. One is basically for acidic region, that is 0.05 m potassium hydrogen phthalate. You know, it is a primary substance. For alkaline pH, you will prepare 0.0 n or molar borax solution. But I also suggest that you should also prepare, because if you are not expert in the weighing and other things, so you can take a saturated solution of potassium hydrogen tartrate, and at 25 degrees centigrade the pH of that solution is, I think, 3.56. So that is also very simple solution to calibrate the pH meter. So that is the first part. Now second part, after the calibration, you need the benzoic acid. Please prepare 0.01 m benzoic acid. There may be some slightly solubility problems, so you can just take the hot water. And titrant is 0.1 molar sodium hydroxide, and you all know that it is not a primary standard substance. So my suggestion is that Please standardize it sodium hydroxide with the help of potassium hydrogen thiolate or oxalic acid, you can standardize it. So now third part is that you take 50 ml of benzoic acid and titrate with 0.1 m sodium hydroxide and measure the pH, volume of alkali added and the pH, and ultimately last we will plot a graph between pH and volume of alkali added, and then we will analyze the results. And you know that basically if I plot a graph between pH and volume of alkali added, generally, because you have also referred many books, many manual, so generally we got such type of plot. And there is a neutralization point. I will explain. So that is a graphical method. So the thumb rule is that I will explain why such type of thing is happened. Is that if it is a neutralization point, so at half neutralization point, if it is 5, suppose if it is 5, so half neutralization is 2.5. So at half neutralization point, the pH is equal to pK. So that is graphical method. And by calculation method also using very famous Henderson-Hasselbalch equation, you can also determine the pK, and then you compare your pK with the literature value. So let us start some very simple theory. I'll explain that this is a very, very famous equation, and it is developed by two scientists. One is, of course, American scientist, American biologist. His name is L.J. Henderson, and another is the Swedish physiologist Hasselbalch. And they actually derived this formula for different types of biological buffer and other things. And general form is, you know, that we have written like that: pH is equal to pK log of is 10. A is it if it is a conjugate base, and it is a weak acid, like that. And again, because I always believe in the research oriented teaching, so I do give always some of the very important literature related to these things. If you are interested to know the study and other, although we are doing experiment, and I think in your undergraduate classes you have already studied all these things, but you can refer, you know, it's one of the most important journal for the student and other things, Journal of Chemical Education. Here you will get the Henderson-Hasselbalch equation and its history and the limitations. So just I will take 1 minute to derive this equation. So you know that if I take benzoic acid, COH, so it will, I can write like H. So it will form, I'll take another pen, is there, okay. Okay, no problem, I'll use these things. So C6, H5, that is good. CO and H, you know, very simple. You can write it is the H conjugate and this H. K, you know, negative H and H. Taking logarithm, of course, log base 10, K log of hydrogen, and you all know, plus log of A negative and HA conjugate species. And we know that we have to determine the pK. You know pK is equal to minus log of K. So if I just convert it into whole negative, so it is pK minus log of H, you all know, that is pH. If it is minus log of conjugate base, so I know, or I can write pK is equal to pH plus log of HA, whatever the acid and A negatives. So this is actually Henderson equations. And what I am just telling you, that at half neutralization point, if I take 1 mole of benzoic acid, so it is neutralized by, because we are using here sodium hydroxide, like that, sodium hydroxide. So half of that acid is neutralized. So if it is 1 mole, so it is converted into 0.5 mole, like that. And remaining its conjugate base is 0.5. So the concentration of A and A is 0.5 mole. So this becomes 0. So in pH is equal to pK. So that is one condition at half. But now I just want to show you, taking your example, because you are taking 50 ml of benzoic acid and 0.1 m sodium hydroxide. So I have to calculate the number of moles of benzoic acid and when it is completely neutralized, like that. It's a very simple calculation. So the thumb rule is that at the half neutralization point, exactly half of the weak acid, benzoic acid, has been neutralized by the added strong acid, sodium hydroxide. So the concentration of this HA, because there must be, I'll just show you the example of, by taking the example of, our case is 0.01 and 50 ml. So I can calculate in 1000, like that. So I can calculate the exact concentration of mole of HA, which must be 5 into 10 to the power minus 4 mole. I'll show you the calculation, and then at half neutralization point it will become 2.5 into 10 to the power 5. You must know that why at pH is equal to pK at half neutralization point. So I am giving here the example. Now you see 0.01 benzoic acid, we will take a beaker and we take this 50 ml, okay, and its concentration is 0.01 and our titrant is 0.1 sodium hydroxide. You know that if I take HA and sodium hydroxide is 0.1, like that, OH, it must be A negative, you know. So calculation of the moles of benzoic acid, you all know the calculation is very simple. As I have already told you, that this is 0.01 moles per liter, and this is 50 divided by liter. So what is our concentration? Mole 5 into 10 to the power 5 into 10 to the power minus 4 mole. I can also calculate the volume of sodium hydroxide required 50% neutralized. So at the half neutralization point, half of the benzoic acid has been neutralized by that sodium hydroxide. So I can calculate the moles of sodium hydroxide added, half of the acid. So again, it is it is 5 divided by half means 2. So as I have told, 2.5 into 10 to the power minus 4 mole. Okay. But suppose I want to calculate the actual volume of sodium hydroxide. That neutralization. You can also simply calculate N1 V1 is equal to N2 V2. That N1 V1. That is also possible. You can calculate the actually volume required to neutralize it. So that is 2.5 to 10 to the power minus 4 divided by mole divided by molarity. So 2.5 into 10 to the liter. Just I converted into in ml. So 2.5 ml sodium hydroxide is required for half neutralization. So what our equation? pK is equal to pH plus log HA A. So that is 2.5 minus 4, so 0. So at pH is equal to pK. So that is called the graphical method. And other method is that we can separately calculate the values of HA, we can separately calculate the value of A negative, and you will get this value. So this is the theory of pK determination of benzoic acid by pH metric methods. So now we will proceed to the laboratory and perform the experiment. Please come with me to the physical chemistry laboratory. Please come. Good evening, student. In the series of physical chemistry experiment demonstration, today we are going to demonstrate one of the important but simple experiment of physical chemistry. Dr. Guneshwari Sahu is with me, Mr. Abhishek Katendri is with me, and 3 students will perform this experiment. And the objective of this experiment is determination of pK of benzoic acid at room temperature. And just tell your name. जोर से बोलिए थोड़ा. My name is M.Sc. Okay, so I think you know the principle of that pK of this benzoic acid, and in my first part I had discussed these things on the basis of Henderson-Hasselbalch equation. We will determine the pK of the benzoic acid. You can also determine the pK of substituted benzoic acid. Say for example, para-nitrobenzoic acid or para-chlorobenzoic acid. Now the experiment is very simple. There are 2 parts. One is first is that because we are using the pH meter, very simple pH meter is enough, and before doing any experiment we have to, which is important है, before starting the experiment we need a pH meter, and it is a simple titration. For that we need a burette and other things. Now why I am saying that, and you know that there are 2 electrodes, it is a combined electrode. Basically in pH meter you all know that there is a calomel electrode and there is a glass electrode, but here that is a combined electrode. Okay. So first part is that standardization of pH meter. Standardization of the pH meter. For that, what we need, स्टैंडर्डाइजेशन के लिए कैसे करेंगे पीएच मीटर, बताइए. कुछ इंपॉर्टेंट है क्या?
सर क्राइटेरिया 1 और 2 का शाम को हम डिस्कस करेंगे, हम दोनों
इनके दिखाओ. कैलिब्रेशन ऑफ स्टैंडर्डाइजेशन कैसे करेंगे? वेरी गुड, आप बताइए. Yes, so we need at least 3 buffer solution. One is for acidic range, we will use the saturated solution of potassium hydrogen tartrate, and the pH of this potassium hydrogen tartrate is 3.56, very simple. And second, you have already prepared, I am very happy that it is potassium hydrogen phthalate 0.05, and that pH is standard value is around 4.02, of course at 25 degrees centigrade, but I do not know today is 30, more than 30, maybe there may be slightly variations in temperature. And third is, borax solution, that is 0.01 borax, and it is, I think, in alkaline range, borax. You must write actual 0.05 or whatever it is, and I think 9.12 or whatever it is, 18 or like that. So what we will do, and I am very happy that you should take the good quality of the reagents or the chemicals for preparation of the solution. That is very important. So here, of course, I am not very happy with this thing because it is the LR. LR means laboratory reagent. Some chemicals are sometimes AR, analytical reagent. But there is a practice. And second is also sodium hydroxide. Why we need the sodium hydroxide? Because when we titrate it, benzoic acid is slightly solubility problem sometimes there. So we will take sometimes hot water. We have to prepare 0.01 m benzoic acid, and we have to titrate with the sodium hydroxide. What is the grade of sodium hydroxide? Sodium hydroxide pellets. Ranbaxy, it is also laboratory reagents. And because that sodium hydroxide is not a primary standard substance, so therefore we have to standardize it with the help of potassium hydrogen phthalate in order to know the exact solution, exact normality of that sodium hydroxide. So after calibration, you can start this experiment and you will measure the different volume of alkali added. We should take a microburette or good quality burette and you measure the pH. So we'll get certain types of plots. Okay. So there are, first is this calibration or the standardization of pH meter with this buffer solution, and second is the titration, and then with the help of both theoretically as well as by the graphical method, we have to determine the because if I take the benzoic acid C6H5COH and C6H5CO and hydrogen, so you can calculate you can write HA. I will show the A negative like that and calculate the K. So just you perform the experiment and Dr. Bhuneshwari will monitor your experiment and show me the graph. So first you see first we have taken the potassium hydrogen tartrate saturated solution and the pH is 3.58. So you note down it 3.5. Now you take the another solution. Take the another solution. Take the another solution, that is the salad. Wash it. हाँ इसको करिए, उसके बाद ग्राफ का करके सबका दिखाएं, 4-5 निकाल लीजिएगा, तो वॉश करिए एंड नोट डाउन इन योर कॉपी ना, टेक द एक्सपेरिमेंट, हाँ रीडिंग को नोट करिए, सामने नोट कराइए ना भाई, ऐसा कि यहाँ लिख दीजिए, कोई प्रॉब्लम नहीं. टेक ए टेबल, टेक द actual pH and your observed. Buffer solution 1, potassium hydrogen tartrate 0.05, potassium hydrogen thalate 0.01 in borax. You take, don't worry for that. If it is 3.56, we are getting 3.59, no problem. If it is 4.02, you check it. There is a book, Determination of Ionization Constant by Albert Sargent. This book is available in the library. Please check it, the values. Just right. 4.12. Yes. No problem. Write down your fair copy so that there will be no manipulation and other things. Wash it and then you start this experiment. Wash it properly. Wash it properly. आप सामने आइए, ग्लाव्स हाथ में रहना चाहिए. यस एंड स्पेक्स. चलिए अभी स्टार्ट कर दीजिए. हाँ चश्मा पहनिए, कल से आप बिना उसके अलाउ मत करिएगा. देयर आर सर्टेन नॉर्म्स फॉर द एक्सपेरिमेंट. एप्रॉन, ग्लव्स, स्पेक्स, that is a safety measurement. What is the value? Okay. Okay. So maybe your alkaline pH may not be very correct. Okay, no problem. So now your pH is calibrated. Now you start the titration. Okay, thank you. You just please continue, okay? And show me the graph. Dear student, in first part, I discuss about the theory of the pK determination by pH metric method. You have seen that I use the Henderson-Hasselbalch equation, and I have also discussed why at half neutralization point pH is equal to pK. And I am very happy that you have determined the different pK values using this pH meter, and I have seen your standardization, and actually you prepared 0.1 sodium, 0.1 m sodium hydroxide, and you titrate with the potassium hydrogen thalate, and I think you are getting concordant reading 10.5. There is no problem because it is quite obvious that the actual molarity of your sodium hydroxide is, so it is not very, it is good because in place of 0.1 we are getting 0.095 molar. So absolutely no problem. When you theoretically calculation the pKa, you should consider these values. Okay. Then I am very happy that you are using 3 buffer solution, and today temperature is I think 27 degrees centigrade in our laboratory. No problem. And first, as I just instructed you, and you do same thing, good. You have taken the saturated solution of potassium hydrogen tartrate. Please check it, these values from your any data book, CRC handbook, data book, or Harned and Owen, anywhere you can check it. But as far as my knowledge is concerned, it is 3.56. And you got 3.58. So no problem. Sometimes we have to clean that combined electrode, put that KCl and other things. So when we fix that pH meter at particular temperature, then you have taken 0.05 m potassium hydrogen thalate. I hope that you have prepared. The actual value is maybe 4.02 like that. So you have slightly higher value. It is 4.12. As per your, I think, from your practical book, practical record, I have seen these things. And third, you have taken the borax, probably 9.18 or something like that, or 4. You are 8.61. Okay. Because you are M.Sc student, there may be some different types of error, some weighing problems, sometimes instrument problem. Anyway, I'm not very unhappy with your results. So now pH meter is okay. Then you start the titration, and I'm using your values like that. And you should use a good microburette. And if you don't have TT microburette, and you must know the least count of that microburette. Generally, because first time you are doing this experiment, so proper steering is required. Suppose this is your electrode, and there is solution, there is a burette, so just steer it. Or even you can take 2.5, 2.75 like that, 0.7, 1.75, 2.25, 2.3, 2.8, like 2.9. Anyway, so you are adding that alkali sodium hydroxide, and you measure the pH, and you are already written in your practical record. So my student, Dr. Abhishek Katendra, he has taken your values and prepared a table. Calculation I will discuss later on. First, I will tell you the graphical method. Then I will explain this thing. So, graphical determination of pKa of benzoic acid. That means you have to plot pH by axis and volume of sodium hydroxide added x-axis. Maybe from 0.25 or like whatever it is, 0.5 like that, up to 10 ml. So with the help of, you can use simply graph paper also for student, but now there is a computer lab and as per my instruction, you use that computer, and that is the plot. And now see that around up to this there is a gradual increase. In somewhere I have seen that like that. So no problem, maybe. So these are the values. But after certain point, I have seen there is a change. I think from 0.5 to suddenly 9 or whatever it is. So that point is maybe when you take the graph paper, so it may be 5, just like so. That is, I consider that is a neutralization point, complete full neutralization point, maybe 5.1 or like that. So as I told you that at half neutralization point, now means I think if 5 is the neutralization point, complete. So half means 2.5. Half neutralization point. Half. So it may be, is there any scale or, okay, no scale is there, so I can, if it is 3, so no scale, no problem. So it is 2.5 is like that. So I can, if I have a scale, approximately this point actually, this point. If it is 3, it is 2.5. Maybe we'll check from the graph or in your computer calculation. It may be, I think it may be 4.2, because every time we'll get the correct value approximately. I am not just, you check. I request all the students who perform this experiment, please use the graph paper and know the exact value of the pK. So that is the half neutralization point. pH is equal to pK. So this is called the graphical method. And you have to calculate the, compare with the literature value. What is the pK of benzoic acid 25 degrees centigrade? Maybe 4.2 or 4.18 or like that. Now another method is that now you can calculate some theoretical calculation also possible. That suppose our Henderson equation is pH is equal to pK is equal to pH plus log of HA and A negative actually, A negative. And I am suppose taking the values of 1.5, I think they have taken 1.5. So the calculation is that how they calculate this HA and A, have you mentioned it? So there is a process of the calculation. How you calculate the HA? I think there is a process. You calculate the HA and A. This is not mentioned in here. So I think HA, suppose total concentration is 0.01 minus A. So we'll getting the value of, in some case 4.31. In some cases I am getting the values of 4.15, like that. You see these things. In some cases it is 4.31 and they just taking the average values is 4.12. Why? Yes, graphical method is 4.20 and Calculation is 4.18. So by that method you can calculate the graphical method. And now the question arises that how can we calculate the HA and A negative? Okay. So you see here, first we calculate the A negative. A, that is conjugate base. So volume of sodium hydroxide, we just use, suppose we are using 1.5. Concentration of sodium hydroxide, our is actually 1, but whatever we are getting, suppose 0.95. So I have to use that. So suppose 1.5 to 0.095, and volume of benzoic acid, suppose it is 50A. So that will get the value of A. Once you get the A, then the concentration of benzoic acid molarity is 0.01 minus whatever the value of A negative. So by that method, we can also calculate and then compare with that pKa for graphical and pKa for theoretical. In some cases, we are getting 4.20 approximately, I am saying. And so I am very happy that today I think 3 students, they have performed the experiment. So let me summarize the thing, that it is a very simple experiment, and you have seen that you are getting the correct value of benzoic acid, but you must be alert, because during the examination, generally we can, in place of benzoic acid, sometimes we can give the para-nitro derivatives of benzoic acid. Like I can give you the para-nitro benzoic acid, in order to test your knowledge and other things. And you will know the Hammett equation or Hammett substituent constants. So naturally, during your class practice, you do the benzoic acid, but in examination, the examiner may change the weak acid in order to check your integrity like that. So naturally, that is different. What is the effect of para-nitrobenzoic acid for the dissociation or the ionization? Maybe para-chlorobenzoic acid like that. It depends upon the availability. So thank you very much.